Hello and welcome to this video from Heybridge High School Maths Department. This video is going to take a look at velocity time graphs. We will only be looking today at velocity time graphs that involve straight lines. So this is a velocity time graph, and as you can see from the graph itself, we put the time in seconds along the x-axis. So that's the horizontal axis, and we put the velocity in meters per second on the y-axis, which is the vertical axis. In a velocity time graph, the gradient of a line tells you the acceleration, and acceleration is the rate of change of velocity over time. So it's how much velocity increases or decreases over a certain amount of time, and we measure velocity in meters per second. We can also measure it in kilometers per hour or miles per hour. When a line segment of a velocity time graph has a positive gradient, this represents positive acceleration. This means that the object represented by the graph is accelerating, it's getting faster. If we have a negative gradient, that's negative acceleration. So the object whose journey is represented by our velocity time graph is slowing down. We also call negative acceleration deceleration. Where we have a horizontal line segment, that means that the object is travelling at a constant velocity. So this means there is no acceleration, either positive or negative, because the object's velocity is constant. We can calculate the distance travelled by working out the area under the graph, and we do this by using something called the trapezium rule, which we will look at in a later slide. So now we're going to have a look at a velocity time graph, and we're going to answer some questions on it. So if we take a look at this first section, we can see that the particle is accelerating quite rapidly. The rate of acceleration then slows down for this second section between 5 and 10 seconds. And if we have a look, we've then got 5 seconds, so from 10 seconds to 15 seconds, where the object is travelling at a constant speed or velocity. And we then have a period of fairly gentle deceleration for 10 seconds, and then we have a period of rapid deceleration for the last 5 seconds of the journey, and the object then comes to a stop. So let's have a look at the first question, and our first question is, what was the velocity of the particle when t was equal to 9? So this is where t equals 9. So this would be the velocity of the particle when t equals 9. And we're going to put a dotted line across there. If you're doing this on a test paper or a question in your book, do make sure that you use a ruler. So we can see here that our velocity, this scale's going up in 2, so 22, 24, 26 meters per second. So when t equals 9, v equals 26 meters per second. So this question is asking us, how long did the particle travel at a constant speed? So as we discussed in the first slide, a constant speed means a horizontal line. It means that the acceleration is 0, so the gradient of the line has to be 0. And the only place where that applies on this graph is here. So this part of the particle's journey is from 10 seconds to 15 seconds. That's a total of 5 seconds. So the particle travelled at a constant speed for 5 seconds. So our next question is, find the acceleration when t equals 9. So t equals 9 here. So we need to find the gradient of the line segment on which t lies. So that would be this line segment. So what's happening to my velocity? Well, my velocity has increased by 10 meters per second. And how long has that taken? That's between 5 to 10 seconds, so it's taken 5 seconds. So I can work out my acceleration by dividing my change in velocity by my change in time, and that's going to give me 2 meters per second. So when t equals 9, the acceleration of the particle is 2 meters per second. Now the second part of the question, when t equals 23. So t equals 23 is here. So again, I need to work out the gradient of the line segment on which t equals 23 lies. And this is going to be this line segment here. So what's my change in velocity? Well, I'm going from 30 meters per second to 20 meters per second. So my change in velocity is minus 10 meters per second. And my change in time, well, I'm starting at 15 seconds and I'm going to 25 seconds. So that's going to give me 10 seconds. And they're asking for an acceleration. So we've got minus 10 over 10. So change in velocity over change in time. And that will give me minus 1 meters per second. Now that's if I'm writing my answer as an acceleration. If you have an acceleration, if they ask for acceleration and the gradient is negative, you must give a negative answer. However, they could also ask you for deceleration. And if they give you a question which asks for deceleration, you would be able to write that without the negative. So you would be able to write that as 1 meter per second because you are decelerating at 1 meter per second. So our next question is, what was the initial acceleration? So we're looking for the gradient of the line segment that begins when time t is 0. So we're interested in this line segment here. So let's have a look again. So our change in velocity will be 20 meters per second. And our change in time will be 5 seconds. So the initial acceleration will be our change in velocity, which is 20, divided by our change in time, which is 4, and that will give us 4 meters per second. And our next question is asking us, what is the initial velocity? So the initial velocity is the velocity when time t equals 0. So we're interested in the velocity at this point. And as we can see from the graph, when t equals 0, in this case, our velocity also equals 0. That means that our particle wasn't moving at all at t equals 0. So our initial velocity was 0 meters per second. So our next question is asking us about finding the total distance travelled. And in order to be able to do this, I need to use something called the trapezium rule. So I'm going to split the area underneath my graph into a variety of shapes. So I will have some triangles, I will have some rectangles and possibly squares, and I will also have some trapezia. And what I'm going to do is I'm going to take each line segment And then I'm going to draw lines from either end of the line segment down to the horizontal axis. So in this case I've got 5 line segments, so I'm going to split my graph up into 5 sections. And then I'm going to label these. So I'm going to have A, B, C, D and E. And then I need to work out the area of each section, so each shape underneath my graph. I'm going to start off with A. So I've got a triangle, so I'm going to do half times base times height, and that will give me half times my base is 5 and my height is 20. So that's going to give me 50. And because my velocity is in meters per second, my distance travelled will be in meters. So in section A of my graph, my particle travels 50 meters. Now let's have a look at B. So B is a trapezium, so I'm going to do half A plus B. Remember, A and B are the parallel sides. Then I'll multiply that by the height, and in this case the height will be the length along the x-axis. So I'm going to get half, and then if I take the left hand line to be A, that's going to be 20. My right hand line will be 30, so that will be B. I'm going to multiply it by my height, which is going to be 5. And that's going to give me, so that's going to give me 125 meters. Now C is a nice easy one because it's a rectangle, so I'm going to do length times width, which is 30 multiplied by 5. So that will give me 150 meters. D is another trapezium. So I'm going to do half. A will be 30, B will be 20, and I will be multiplying by 10 because my height will be here again, and that's 10. So that will give me 250 meters. And then finally I've got E, and E again is a triangle. So I'm going to have half times my base, which is 5, times my width, which is 20. So that's going to give me another 50 meters. And then to find the total distance travelled, I'm just going to add all these together. So I'm going to have 50 add 50 is 100. 150 add 250 is 400. Add the two together gives me 500. And then add the 125. So my total distance travelled will be 625 meters. And now we're being asked to find the average speed over the whole journey. So you will probably remember from when you did speed, distance and time or distance speed graphs, the average speed equals total distance divided by total time. Okay, so we worked out our total distance in the last question. That was 625 meters. We also know that the total time taken is 30 seconds. And if I divide 625 by 30 seconds, that will give me 20.8 meters per second to 3 significant figures. So the average speed over the whole journey is 20.8 meters per second. Thank you for watching.